Another example, which is a very important example actually. Let's say we have the same rod that we had in the previous problems. In the first one, if you remember, we calculated the mass moment of inertia of this rod about an axis which is normal to it at the middle, at the center of gravity of it. Now let's say the axis is here. This is axis, let's say XX, like the previous one. And I want to find the mass moment of inertia of the same mass about this one. So Ixx, based on definition, is equal to integral of r squared dm. And I can choose this tiny element with the length of dy. And let's say the distance of it from the x-axis is y. So dm, which is in this integral, is going to be rho dy, the mass of this tiny element. And r, which is the distance of my element from the axis, is y. So it's going to be equal to integral of y squared dm, which is rho dy. Now, what are the boundaries of this integral? When we are moving this element from this end of the rod to the other end of it, y goes from 0 to L if the length of the bar is L. So the boundaries of the integral is going to be 0 to L. This is a simple integral. It's going to be rho times 1/3 of y cubed. From 0 to L is going to be L cubed. And rho L is the mass, right? The mass of the rod is density per length times L. So if you replace rho times L with m, then Ixx is going to be equal to 1/3 of mass times L squared. This is a very important equation that we are going to use it. Sometimes we use it to solve more complicated problems. So just to summarize, for a rod with the mass of m and length of L, if you want to find the mass moment of inertia about this axis, it's going to be 1/12 ml squared. If you want to find it about this axis, the mass moment of inertia is going to be 1/3 of ml squared. This is 4 times bigger than this one, right? So it means it is much easier to rotate it about this axis rather than this point, right? Or this axis versus this axis. If you want to rotate it about this axis, you need less torque. If you want to rotate this rod about this axis, you need much more power, more torque. Right? That's the physical meaning of this I.